Okay, now degree of dissociation or degree of ionization alpha of weak electrolyte. Now, what is degree of dissociation or degree of ionization alpha? As I have told you, when you dissolve some weak electrolyte in water, the electrolyte do not undergo complete dissociation. What fraction of molecule undergo ionization, and that is called degree of dissociation or degree of ionization. Now, for weak electrolyte, how to determine the alpha value? I mean, how to determine what is the degree of dissociation? I mean, how many fraction of molecule undergo dissociation? This one given by one scientist called Austral. That's why this is also called Austral Dilution Law. This is also called Austral Dilution Law. OSTWALD. Now, first time I will give you what is degree of dissociation or degree of ionization. The definition is the fraction of molecules that ionized in solution for weak electrolyte is called degree of dissociation or degree of ionization, and which is represented by the symbol alpha. So always remember alpha value always in fraction. If it is strong, then alpha value is considered as 1, I mean 100% ionized, then it is considered as alpha value 1. And for weak electrolyte, since it is not completely ionized, that's why alpha always will be fraction. Because the total value of alpha is always considered as 1. So for weak electrolyte, it may be half, it may be 1/3, it may be 1/4, like that, depending on how much percentage undergo ionization. If the electrolyte undergo 50% ionization, you consider as alpha value half. If it is 25% undergo dissociation, then you consider it as 1/4 alpha value, like that. I mean, alpha value always represented by fraction. So the fraction of molecules that ionize in solution for weak electrolyte is called the degree of dissociation or degree of ionization alpha. Now, let us consider a weak acid, I mean a weak electrolyte, a weak acid which is dissolved. Let us consider a weak acid which is ionized as follows. Suppose that weak acid is acetic acid CH3COOH. When you dissolve in water, then it produces two ions. What are the ions? You know, this is acid. Acid always release H plus ion. So from the acetic acid, some amount of H plus ion will be released. Because it is weak, it cannot undergo complete dissociation. So the H plus ion released from the acid combine with water to produce hydronium ion H3O plus. And the negative ion will be CH3COO minus. I mean, this acetic acid release the H plus ion, and the H plus ion combines with H2O, it produces H3O plus, and the negative ion will be CH3CO minus ion. And since it is weak, it do not undergo complete ionization, and that is why you will get one equilibrium between the dissociated ions and the undissociated molecule. I mean, inside the solution, you will get ions also, you will get some undissociated molecule also, because it do not undergo complete ionization. Now, in chemical equilibrium, you have got, there is a law called law of mass action. By applying the law of mass action, K is equal, you can write multiplication of the concentration of product, I mean concentration of the acetate ion into concentration of the hydronium ion, I mean multiplication of the concentration of product divided by multiplication of the concentration of reactants, I mean concentration of acetic acid into concentration of water. This is called law of mass action. You can find out the dissociation constant K. K is equal nothing, multiplication of the concentration of product divided by multiplication of the concentration of reactant. Now, here, as you know, this is weak electrolyte, so it releases little amount of H plus ion, and that little amount of H plus ion combined with little amount of water to produce hydronium ion, and that is why maximum of water will remain as H2O, and that is why the concentration of water remain almost constant in the reaction. Suppose, what I want to say, suppose there are 100 molecules of acetic acid, 100 molecules of water. Among 100 molecules, only 5 molecules undergo breaking. So 5 H plus will release, and that 5 H plus combined with only 5 H2O molecule to produce 5 hydronium ion. Other 95 water will remain there. That is why the amount of water remain almost same. And that is why this concentration of H2O is considered as constant, and that is why you can multiply with the dissociation constant K. So K into H2O is equal, you can write concentration of CH3CO minus into concentration of H3O plus divided by concentration of CH3COOH. This K into H2O, this you can write as Ka also. A for acid, because we have considered acid, that's why it is called Ka. If you consider some weak base, then it is called Kb, like that. B for base, A for acid. So Ka is equal, you can write concentration of CH3CO minus into concentration of H3O plus divided by concentration of CH3COOH. This Ka is called dissociation constant of the acid. If you consider base, then you have to write Kb, and which is called dissociation constant of base. Now, like this way you can find out the dissociation constant. After getting dissociation constant, let the initial concentration of the acid is C mole per liter. I mean, initially the concentration of the acetic acid we consider as C mole per liter, and let alpha is the degree of dissociation. I mean, alpha part undergo dissociation at equilibrium. When the reaction is at equilibrium, then alpha part undergo breaking. Okay. Now, our acid is acetic acid CH3COOH. When it dissolves with water, it produces two ions, acetate ion CH3CO minus and hydronium ion. So we have considered initially, I mean at the starting point, initial concentration of acetic acid we consider as C. Initial means at the beginning when the time is 0. Initially the reaction will not proceed, because to proceed the reaction minimum 1 second required. So initial matlab time 0, that is why there will be no product concentration will be 0. Initially the concentration of product is always 0, because to form the product it requires some amount of time. Initial means time 0. Now as the time proceeds, some amount of product will form and the reaction gain the equilibrium state. And when the reaction gain the equilibrium state, at equilibrium, let alpha part of C undergo dissociation. If alpha part of C undergo dissociation, now how much will remain? Initially how much? C. Now how much dissociate? Alpha part of C undergo dissociation. So how much remain now? C minus C alpha. This part will remain. This part undergo breaking. Initially this much, so this minus this, you will get the present concentration of the reactant. Since it undergoes C alpha undergo dissociation, that is why the concentration of acetate ion will be C alpha, concentration of hydronium ion will be C alpha. So like this way you can find out the concentration of the reactants and products at the equilibrium state if you know about the degree of dissociation. Now you have got the concentration of acetic acid, you have got the concentration of acetate ion, hydronium ion. So now you can find out the value of Ka. As you have got Ka is equal concentration of acetate ion, hydronium ion divided by concentration of acetic acid. So now you put the value, concentration of acetate ion, you have got acetate ion is C alpha into concentration of hydronium ion C alpha divided by concentration of acetic acid C minus C alpha. Just you put the value of the concentration in Ka equation. Then this one you can write C square alpha square C into 1 minus alpha. So 1 C will be cancelled. Ultimately you can write C alpha square divided by 1 minus alpha. Now, since the acid is very weak, so the degree of dissociation will be very, very less. If it is strong, then it will more ionize. But since the acid is weak, that is why the alpha will be very, very less than 1 because degree of dissociation is very small. That is why you can write like this. Since the acid is very weak, so alpha will be very, very less than 1, and that is why 1 minus alpha is equivalent to 1. That means you can write Ka is equal C alpha square, or alpha is equal, you can write root over Ka by C. And this is one of the relation by which you can determine the degree of dissociation alpha. What is Ka? Ka means dissociation constant of acid. What is C? The concentration. And what is alpha? Degree of dissociation. Now you can see here, this is degree of dissociation and this is concentration. The degree of dissociation is inversely proportional to concentration. I mean, if concentration is more, degree of dissociation will be less. If concentration is less, degree of dissociation will be more. Since the law is applicable for weak electrolyte, for weak acid, weak base, that means when you decrease the concentration, the dissociation will be more. I mean, suppose there is one weak electrolyte, you dissolve in water, a little amount of molecule undergo dissociation. In that solution, if you dissolve some amount of water, when you add water, what about the concentration? Concentration going on decreasing, so the degree of dissociation will going on increasing. I mean, as the amount of water going on increasing, the degree of dissociation going on increasing, and which is called the Austral Dilution Law. So according to Austral Dilution Law, for weak electrolyte, the degree of dissociation is inversely proportional to the concentration. If concentration is more, degree of dissociation will be less. This is called Austral Dilution Law.